This one is C10H13N. It has 5 double bond equivalents. We have a 4H in the aromatic region. That's going to be C6H4, or two things connected to an aromatic ring. We're going to have 1H broad here, 2H, 3H, and 3H. Let's get those out the way first. The two 3H's will be two CH3s. We have a 2H, that's going to be one CH2. And then we have a C and O, a double bond equivalent, so that'll be a C double bond O, and an NH will round it out. So we don't have a C double bond N here, so I can be pretty sure we're looking at a C double bond O. And everything's counted down to 0, so this should be the correct pieces. So we're looking at the CH3 groups, and you can see that we know that the CH3 groups cannot be next to CH2s, and that's the reason for that is because they're single peaks. If this CH3 was next to a CH2, the CH3 would appear as 3 peaks because it's adjacent to 2 hydrogens. So I know that that must be apart from it. I also know this CH3 must be apart from this CH2 as well, so they're not joined together. So now we can go ahead and try and order these up and put them in the right places. And I might try something like this. And the reason I would is because of the way that the aromatic ring is split apart. One thing, if you look over here, you can see that we've got between 7 and 8, we've got these peaks, and they're fairly widely split. And the reasoning I would give for that is because when you've got a singly substituted aromatic ring, that tends to split the ring into two places, and it tends to be centered at around 7.5 ppm than when a C double bond O is connected to the aromatic ring. And in this instance, that's what we're seeing here is the ring tends to be split apart. Because it's got two things on it though, the splitting is a bit different than what we see when there's only one thing connected. But still, there seems to be a pretty good reasoning for why the C double bond O might be connected to the aromatic ring. As I said earlier, there's no way that we can do something like this because the CH2 and the CH3s have to be separated. So this would, I'd be fairly confident in this being my structure. The other thing that we can sort of look at here would be the placement of the CH2 and the CH3 being a little bit over 2.5 ppm, which might indicate that they were connected to nitrogen as opposed to being connected to a C double bond O group. C double bond O's connections tend to be between 2 and 2.5 ppm, so that's why I'm fairly confident that my CH3 group would be here.